Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem. Alright, so for this video, I'm going to be solving the equation x to the power of x is equal to x to the power of 2. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite this problem down here so I have a little more solving space. So my equation is x to the power of x is equal to x to the power of 2. Now the first thing I'm going to do is divide both sides by x to the power of 2. So then these two cancel out, and I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So x to the power of x over x to the power of 2 is going to equal x to the power of x minus 2, which is equal to 1. And now what I'm going to do is I'm going to take the ln, or natural log, on both sides. So I get ln of x to the power of x minus 2 is equal to ln of 1. Now the reason I did this is because logarithms have a special property where if I have something in the form ln a to the power b, I can simply move this exponent b to the front. So this is the same thing as b times ln a. So in this case, I have ln x to the power of x minus 2, and I can think of x minus 2 as b and just move it to the front. So this is the same thing as x minus 2 times ln x is equal to ln 1. So now, ln 1 is actually equal to 0. So I get x minus 2 times ln x is equal to 0. And now this gives me two equations. I get x minus 2 equals 0, and also ln x is equal to 0. So, for x minus 2 equals 0, this is a simple equation. All I have to do is add 2 on both sides, and I get x is equal to 2. So that is my solution. And now for ln x equals 0, what I'm going to do is take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of 0. And the reason I did this is because e and ln x cancel out, so I'm left with x is equal to e to the power of 0, which is 1. So now to check, my equation is x to the power of x is equal to x to the power of 2. So if I plug in 2, I get 2 to the power of 2 is equal to 2 to the power of 2, meaning 4 is equal to 4. If I plug in 1, I get 1 to the power of 1 is equal to 1 to the power of 2, meaning 1 is equal to 1. So both of them are right.